Hello, and welcome back to Pre-Calc. This is Unit 8, Section 3, and what we're going to be doing is graphing secant and cosecant functions, okay? So we want to analyze the key features of these types of functions, from equations and graphs. Okay, so remember something. Let's talk about cosecant, okay, first. Y equals cosecant x. Remember that this is the same thing as y equals 1 over sine of x, okay? And so remember that these are reciprocal functions, okay? So what we want to do is first look at the sine graph, and that's what we see here, all right? So this graph down here is y equals sine of x, okay? So we're going to use these graphs to kind of help us, okay? And what I want to look at is a couple of points here. All right, so the first thing I want to look at is y equals, let's look at y equals sine, or not y equals, let's just do sine of, say, pi over 6, okay? So if I look at sine of pi over 6, all right, pi over 6 is right here, okay, on your graph, all right? And the y value we have here is 1/2, okay? So sine of pi over 6 is equal to 1/2. Now what I want to do is now look at cosecant of pi over 6. Now what I know about cosecant of pi over 6 is it's the reciprocal of sine of pi over 6, so that's just going to be 2. Okay, so that's what I know. All right, now this is also going to be the case if I were to evaluate sine of 5 pi over 6, would also give me 1/2. Okay, same thing here with cosecant of 5 pi over 6, and that's going to give me 2. All right, so, and let's put this in here, 5 pi over 6 is right about here on our graph, okay, and that gives us those points. All right, but when we look at the cosecant values, okay, notice how we have, at pi over 6, we have values of 2 and 2, okay? Now, the next point I want to look at is sine of pi over 2. Okay, and that's going to give me a value of positive 1. Now, if I find the reciprocal of that and do cosecant of pi over 2, that's going to give me also a value of 1. So I have these points here, you know, pi over 2 is at 1, and the same reciprocal function is also going to be there as well, okay? So we have those values there, all right? Now, the next thing I want to do is look at the other side of this, okay? Look at the values between 0 and negative pi. So let's do sine of negative pi over 6. Let's look at sine of negative 5 pi over 6. And let's look at sine of negative pi over 2, okay? Sine of negative pi over 6 is just going to be in the other value. That's just going to be negative 1/2. Okay, same thing with negative 5 pi over 6, negative 1/2. Okay, and so those values are found here and here. Okay, so this is negative pi over 6, negative 5 pi over 6. Okay, we have those values. Now, if we find the reciprocal of those, we're going to do cosecant of negative pi over 6, and that's going to give us a value of negative 2. Okay, same thing with cosecant of negative 5 pi over 6, and that's going to give us negative 2 as well. So we're going to put those points down here and here, okay? And then at negative pi over 2, we have a value of negative 1. Okay, so sine of negative pi over 2 is negative 1. And that's going to be the same thing for cosecant of negative pi over 2 is also going to give us negative 1. Okay, so we got these points here. All right. Okay, so now what I want to look at is I want to look at sine of 0, and I want to look at sine of pi. Okay. Now, when I have sine of 0, okay, look at what the y value we have here. It's a value of 0. Okay. Now, same thing's going to happen at pi. We're going to get a value of 0. The y value on the unit circle is 0. So, if I find the reciprocal of that, it's undefined. So cosecant of 0 is undefined. Same thing with cosecant of pi. That's also undefined. So what's interesting is that at 0, because it's undefined, what we're going to have is we're going to have asymptotes. Okay? And so we've got these asymptotes here. And that's going to occur at 0, at pi. It's going to occur again at 2 pi. It's going to also occur at negative pi. And at negative 2 pi. Okay? So kind of unique, all right, but that's just because those values are going to be undefined. Okay, so wherever it's undefined, we're going to have asymptotes. Now what you want to do is try and fit the graph, okay, and if we're talking about asymptotes, you know, and it's kind of a weird concept, but like, you know, as sine, you know, as you approach 0, okay, on sine, on the x-axis, as you approach the y value is 0, the reciprocal of that would actually go to infinity. Kind of a weird thing to think about, but that's what we've got. But if you connect your graphs, it's just like a bunch of u's, yeah. And so, same thing over here, you know, I know these values are going to be at negative 2 and negative 2, and you can draw your graph in like this, okay? And then we'll fill it in like that. And what I do, you know, in order for me to graph these, I basically have to look at my parent function, which is my sine graph, use that to help me graph my cosecant function, okay? So now, let's talk about something. Let's talk about our domain of this graph. So our domain is any real number except n equals n pi, where n is any integer. Now, it's really weird when we say this because we have asymptotes that are cyclic, and they occur at any value of pi, or any multiple of pi. But the multiple, when we write that, n has to be any integer. Integers are 0, 1, 2, 3, 4, 5, 6, and they're opposites. And so that's how we get those values, okay? And that's where we can identify our asymptotes. Our asymptotes exist at those values, x equals n pi, where n is any integer, okay? These are also periodic, just like your sine function, and they have the same period as your sine function because, you know, they repeat after every 2 pi units, okay? And that's how we get that graph. Now your range, notice your range, your values are strictly going to be less than or equal to negative 1, so they're going to be below negative 1, or they're going to be larger than or equal to 1, okay? So when we have cosine values, we're actually not going to have values in between, you know, negative 1 and positive 1, and that's how we get those, all right? Now we can do the same thing to develop our cosecant, or I'm sorry, our secant graph. Okay, we can pretty much do the exact same thing. Let's look at a couple of things here. So with secant, we first want to look at our cosine graph. So remember, this is our graph of y equals cosine of x. Okay, And let's look at a couple of values for that. Let's do, I'm going to do y equals, let's do cosine of pi over 3. Let's do cosine of negative pi over 3. And let's do cosine of 0, okay? Cosine of pi over 3 is going to be the value of 1/2. Same thing with cosine of pi over negative 3. That's going to be a value of 1/2, all right? Cosine of 0, the x value on the unit circle at an angle of 0 is going to be 1, okay? So if we were to find the reciprocals of these, and we'll use red, if I do secant of pi over 3, that's going to give me 2. If I do secant of negative pi over 3, okay, that's going to give me a value of 2. If I do secant of 0, that's going to give me a value of 1. So as I come in here, okay, pi over 3 is over here. Pi over 3. This is negative pi over 3. Okay, values on our graph of 1/2. And then at 0, we've got a value of 1. Okay, when I do secant, let's plot those points up here at 2, 1, and then at 2 again. Okay. And let's think about what happens when we plug in cosine of pi over 2. Okay, cosine of pi over 2 is equal to 0. Okay, the x value on my unit circle at 90 degrees is 0. So if we were to then do secant of pi over 2, that would be undefined. Okay, same thing with, let's do cosine of negative pi over 2. Would also be 0. So then secant of negative pi over 2 would also be undefined. So that's where we have our asymptotes. So we have pretty much the exact same thing. It's just that our graph is shifted over. Much like how sine and cosine are just shifted over 90 degrees, okay, from each other, the same thing's going to happen here on these graphs. Okay, so our asymptote is going to be at pi over 2, 3 pi over 2, okay, negative 3 pi over 2, okay, and we can have the same thing, that same U-shaped graph, okay, and it's going to happen at pi, get the same thing going down, have the other one, okay, and we can fill it in like that. So once we know what our graph looks like automatically, okay, we can just use that to graph the other ones, all right? So now the tricky thing over here is to then talk about, well, what's our domain, okay? And it's going to be all real numbers except except something pi. We have to come up with some sort of like algorithm that tells us this. Now let's think about where we have our asymptotes. All right, so let's just think about this because we didn't write this. I didn't put that down for a reason. So our asymptotes occur at pi over 2, at 3 pi over 2, at 5 pi over 2, and so on. So we have to come up with an algorithm that helps us to figure this out. So notice how our denominator here is 2, okay? Except for we have this. I'm going to do, so to write an odd, and you're right, like these are all odd numbers, pi over 2. So what I want to do is do this. I'm going to do pi over 2 out front times 2n minus 1. okay, where n is an integer. Okay? And let's think about that. If I plug in, you know, any integer, if I plug in 0, I'm going to get 0, 2 times 0 minus 1. That's still going to give me like negative 1 pi over 2. Okay? If I plug in, say, like 1, 2 times 1 minus 1, that's going to give me 2 times 1 is 1, minus 1 is 1, over pi over 2. So that gives me pi over 2. If I tried, like, say, 2 times 2 minus 1, that's going to give me 2 times 2 is 4, minus 1 is 3, pi over 2. Okay? So that's tricky. That's hard to do. Okay? But that's the idea. All right? And so that's where our asymptotes occur. So if we want to describe our asymptotes, okay, those occur at x equals pi over 2 times 2n minus 1. Okay? And that helps us develop, because they're cyclical. Okay? I don't have, like, you know, they're going to keep repeating. And so that's why I have to write, like, my own function to develop where my asymptotes are. Okay? This is periodic by 2 pi. All right? So the period is 2 pi, same as the other ones. And then our range is the same as the other ones as well. And that's going to be that y is going to be less than or equal to negative 1. And, I'm sorry, or, doesn't really matter. Y is greater than or equal to positive 1. Okay? And that's where we get those values. All right? So now let's take a look at some of these transformations. Okay? So if my graph, if I wanted to graph the line cosecant of x plus 2, all right, let's do this. Let's graph our generic sine function, and we're just going to do one period of that. So start at 0, pi over 2 is 1, pi is 0, 3 pi over 2 is negative 1, pi is here. Okay, so here's my graph of my generic sine function. Okay, now if I wanted to do, you know, that, and let me write that here, that's y equals sine of x. If I wanted to graph y equals cosecant of x, okay, I would want to do, you know, wherever I have a 0 on my sine graph is where I have an asymptote. Okay. And then wherever I have a 1, that's where I put my minimum and maximum. And then I draw my graph going in this direction. Okay. So now, if I wanted to graph y equals cosecant x plus 2, then what I would do is I would just move all these points up 2 units. Okay? Same thing down here. I'd move these points up 2 units. All right? And then I could just graph that function. And that's how we'd graph that. Okay? So always think about, you know, your regular sine graph, regular parent function, and then change them accordingly. Okay? All right, so if I'm going to go on this next page and graph y equals secant of x minus pi, okay, think about what this graph is going to do. It's going to take your secant graph and it's going to move it over pi units. Okay, so this is going to shift right pi units. Okay, so what I'd want to do, let's just graph our secant graph. So let's graph first y equals cosine of x. Okay, that's 0, 1, pi over 2, 0. I don't want to, hold on, let's do 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi is at 1. Okay, so here's our other graph. Okay, let's draw in our asymptotes for y equals secant of x. So we're asymptotic here, asymptotic here. Here's my graph that goes like this. My graph that goes here and here, and then this graph that goes up. Okay, so there's my secant graph. Now what I want to do is move all these points over pi units. Okay, and so actually, you know, if you think about what's going to happen, I'm going to move this point over pi units this direction. Okay, this point is going to come over pi units this direction. And what you have, the asymptotes are actually going to stay the same because the asymptotes are pi units away. But what this graph is going to do is just kind of be opposite of what we already see. Okay? And so the graph in blue is what we see for secant of x minus pi. All right? Let's take a look at the next one. Now, cosecant of 4x. Now, let's think about what's happening with cosecant of 4x. Let's look at y equals sine of 4x. Now, 4x, you know, this is periodic. Let's just quickly draw our sine graph. Okay, 0, 0, 0, 1, negative 1, boom, 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 boom. Okay, remember this is a period of 2 pi. So now what I want to do, my b value here is 4, so I'm going to do 2 pi over 4, which is now going to give me a new period of pi over 2. So now what I want to do here is draw my sine graph, and let me do sine of 4x in red, y equals sine of 4x in red. All right, and so if my period is pi over 2, okay, that means we're going to split this up like so. All right, split it up like so. All right, and I'm just cutting it, each of these pi over 2's in half. All right, and we're going to have 4 different periods within 2 pi. Now, if we want to graph y equals cosecant of 4x, we need to draw in our asymptotes. Wherever our graph crosses the x-axis, that's where our reciprocal graph has asymptotes. And then what we do is then we go through and just draw in our u's like so. Now remember that when you're doing this, I mean this isn't exact, this is pretty darn good, all right, but I'm using all those things that I had previously learned about, okay, when graphing these to do them, all right. And so, you know, what you want to do, you know, always try this on paper, but Desmos is your friend. So I hope you enjoyed this video, and we'll talk to you soon. See you later. Bye!